Hello, welcome back to our channel. Today we are going to discuss about the gravitation chapter. So in this first we are giving more preference to what are the Kepler's laws. So this is starting with Kepler's laws only. Based on that only, what do you say? That all planets are revolving around the sun in elliptical path. That is called what? Law of orbits. See, all planets are revolving around this. First one is the law of orbits. Law of orbits. According to that, what we are getting is, see, all planets are revolving around the sun. In which path? Elliptical path. This is the major axis and this is the minor axis. This half of this one is called the semi-major axis. It is represented by a. Where is the position of the sun? This we can observe here or here at any location. We can observe that is the location of the sun. So all planets are revolving around the sun in elliptical path. That is called the law of orbits. Then law of areas. Second one is the law of areas. Law of areas. It covers equal areas in equal intervals of time. Planets are revolving around the sun. These are covering equal areas in equal intervals of time. Suppose 1000 meters square. It takes 1 hour. Okay. So same area, next position, wherever it is area is same, means same time it will take. This is called the law of areas. Suppose here you can take this area is A1 and this area is A2. Suppose A1 equals to A2, means same time it will, here and here covering this distance, it will take same time. That is called the law of areas. So simply you can say that dA by dt is equals to constant. Is equals to constant. Instead of dA, what we are writing? Half r square theta. So half into r square into d theta by dt, rate of change of displacement, angular displacement is giving the angular frequency. This is called the law of areas. Then third one is the law of time periods. What is the law of time periods? He has given that relation between time period and semi-major axis. Square of the time period is directly proportional to cube of the semi-major axis. It should be right, T1 by T2 equals to A1 by A2 whole to the power of 3 by 2 also we can take it. So these are the law of orbits, law of areas, and this is the relation between time period and semi-major axis cube. Suppose T1 equals to A1 equals to 4 meters, then A2 equals to 16 meters. Then how to find out the time period? T1 by T2 equals to 4 I am writing 2 square, then 16 I am writing 4 square, 3 by 2. This 2 cancel. T1 by T2 is how much? 2 cube is the 8 and 4 cube is the 64. So our answer is 1:8. Like that, when you know the areas, that semi-major axis, we can find out the ratio of the time periods. Like that, when you know this, we can find out the dA by dt. When you know the A, we can able to find out this dA by dt. This is called the aerial velocity also. This is called the aerial velocity. These three belongs to Kepler's laws. Then we are going to discuss about Newton's law of gravitation. Newton's law of gravitation. This chapter, electric charges and fields, then magnetism and matter. If you are having like a grip on one topic, no, automatically you will get another topic also. See, the first person who said, he said that between massive objects, between me and this board, and between me and wall, between two walls, which force is acting? Those are having the massive bodies, those are having the masses. So between that, gravitational attractive force is acting. But why we won't feel that one? Always you remember that gravitational force is the long range and weak force. But where we should observe that all planets are revolving around the sun due to the gravitational force, and moon is revolving around the earth because of the gravitational force only. So this is belongs to the gravitational force. But how to calculate the gravitational force between the massive bodies? Look here, we are taking two massive bodies. One is the M1, another one is the M2, and both are separated by a distance of how much? R. Here this force of attraction is directly proportional to m1, m2 and inversely proportional to distance square. More distance, less force. Less distance, more force you should observe. Even it depends on the masses also. Why moon is revolving around the earth is having the more mass comparing with the moon. Then when you are writing, you are getting one constant. This G is called, the capital G is called the universal gravitational constant. This is called the universal gravitational constant. This G value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Newton meter square per kg square. So this is about the Newton's law of gravitation. We do one problem also. If m1 equals to m2 equals to 4 grams, then r1 equals to 2 meters. Find, otherwise you can take it 6.67 meters. Find gravitational force. How to find out? F equals to, you know that G value is the 6.67 into 10 to the power of minus 11. 4 square means 16, but it is grams. Gram square means 10 to the power of minus 6 divided by 6.67 into 6.67, because it is whole square. 1 is cancelled. Then F equals to 16 by 6.67 into 10 to the power of minus 70 newtons. Like that we can find out the gravitational force of attraction between the massive bodies. And one more point I want to share with you, null point. Where we should get the null point. See, this concept is coming in magnetism and matter and electric charges and fields also. Look here. This is the m1 and this is the m2. Between the distance is how much r. We are placing one more mass here. Here the distance is the x. This is the r minus x. We feel that here gravitational force is equals to 0. That location is what? X equals to r by under root m2 by m1. Always you take it m2 is the more than m1 plus 1 only. Plus 1 only, because gravitational force is the attractive force, we can take plus 1. We do one problem also. If r equals to 8 centimeters, m2 equals to 16 grams, then m1 equals to 1 gram. Then where we should get that null point? X equals to 8 by under root m2 by m1 is the under root 16 is the 4. 4 plus 1 is the 5. So x equals to 1.6 centimeters. So from here at 1.6 centimeters we can observe the null point. Suppose the question is from m2 where we should find out the null point, means simply how to do 8 minus 1.6 is, it gives the null point location from the m2 mass. So it depends on the situation, you can solve that. While doing the problems you must read the question properly and what they are asking you have to read, then only you can give the answer. Now we are going to discuss about relation between small g and capital G. Relation between small g and capital G. See, you can say that capital G is the universal gravitational constant. It is constant only, this value, it never change. But small g is changing. How it is changing we are discussing now itself. Relation between small g and capital G. See, this is the mass of the earth m and this is the radius of the earth r. You are here, your mass is m. Just now I said F equals to g m by r square. But instead of F we are taking gravitational force, nothing but weight of this one or gravitational force, anything you can take it. After simplification, G equals to gm by r square. Look here, if mass is constant, if m is constant, what we are writing? G1 by G2 equals to R2 by R1 whole square. R2 by R1 whole square. If suppose you should consider mass also, G1 by G2 equals to M1 by M2 into, this is inversely proportional, means we can take it R2 by R1 whole square. One is the earth, another one is the moon. When we are going through the comparison of this one, we are using these formulas. See, G1 by G2, this is earth means you can take it 9.8. And this is the moon means you can take it 9.8 by 6, 1 by 6 times less than the earth, moon of the mass acceleration due to gravity. Then few more cases we are discussing here. See, this G equals to, we can write it. Earth is having the spherical shape. Instead of mass, what we are taking, volume into density. Volume of the Earth is the 4/3 by R cube into density divided by R square. So this one cancel. So G is directly proportional to 4/3 is constant, capital G is constant, pi is constant. Simply you can take it R into density. See, if density is constant, here mass is constant means you are getting this relation between G and capital R. But G1 by G2 equals to what we are taking, R1 by R2. So while reading the question you should remember that suppose if R1 equals to 6400 kilometers, G1 equals to 10 meter per second square, G2 equals to 10 by 6 meter per second square. Find R2. If rho is constant, density is constant. Density is constant means don't go for this one. We have to use this only. G1 by G2 is the, anyway it should be right 10 by 6 equals to R1 is 6400 divided by R2 we should find out. So when it will reverse, R2 equals to how much? 6400 by 6. 6 1 jump. Then 6 6 36. So 1066 kilometers. Like that we can find out the radius, depends on the given data. So the main thing is which parameter is constant. If mass is constant, you can go through this. G is directly inversely proportional to R square. If density is constant means we can go through this one. So this is the relation between small g and capital G. Now we are going to discuss about the gravitational potential. What is the gravitational potential? Suppose this marker is at infinite distance. How much work is required to bring the unit mass from the infinite distance? That is called the gravitational potential. What is that? Generally you can take it work done equals to how much force is there, F by W equals to, this is coming in the case of electric potential, in the case of gravitation also. Generally in the case of potential we are taking W equals to V by Q. W equals to V equals to W by Q. So here instead of Q we are taking M. This is the gravitational potential. This is the gravitational potential. This is nothing but work done. We should write it. This is potential energy also. What is the gravitational potential energy? Minus Gmm by R we are taking. Suppose this is the earth and the mass is here. R plus H is the distance. In this case, gravitational potential energy is minus Gmm by R plus H. Don't forget about this gravitational potential energy. If that H is very less than R, you can go through this formula, and we should consider the height also. We can go through this formula. Okay. Then we are going to discuss about, once you look this one, variation of G with altitude, height. You are climbing some mountains, you are going to certain heights with the help of the flights, rockets and all this. What about the acceleration due to gravity? That's why this question name is what? Variation of G with altitude. Variation of G with altitude. Look. Variation of G with altitude. Altitude means, don't confuse, this is the height. Just you remember two formulas. Already you know that G equals to Gm by R square. Based on this, G by Gh or Gh by G. What we are taking? First one is the Gm by R plus H whole square. Second one is the Gm by R square. This one cancel. Simply you can remember that R by R plus H whole square. So Gh equals to G into R by R plus H whole square. This is the formula. Suppose if G equals to 10. R equals to 6400 kilometers. Then H equals to 2 times of that R. Then how to do this calculation? GH equals to 10 into R by R plus 2R is how much? 3R whole square. This R cancel. 1 by 3 whole square means how much? 10 by 9. 10 by 9 means, look here, 1.1 you are getting. 1.1 meter per second square. Look here. Earth radius is the 6400 kilometers. When you are going 2 times of that earth radius height, see, acceleration due to gravity is how much? That's why even on moon also G value is very less. That's why they are floating, and like that they are wearing different types of suits for walking and all these things. See, G value how much? From this, what is the clarity? When we are going certain height, acceleration due to gravity is decreasing. Acceleration due to gravity is decreasing. And one more case you should remember, that if height is very less than R, simply you can remember that GH equals to G into 1 minus 2H by R. 1 minus 2H by R. So here that height is very less, they will give in that. So at that time no need of using this. This is accurate, you can use it anyway. But they will mention small height means instead of this you can use this one. Easily we can do the calculations. So here also, suppose H equals to R by 2. H equals to half of that radius. Then GH equals to G into 1 minus 2 into R by 2R. 2R cancel. Then what we are getting? 1 minus 1, 0. G height, that is the 0. Suppose this is the 3. This is the 3. Then you are getting this one cancel. GH equals to G into 3 minus 2 by 3. Like that you are getting. Then G equals to G by 3 times. On earth it is 10 meter per second square, but when you are going that 1/3 of that radius of that one, you are getting that is decreasing to 1/3. Like that we can use that variation of G with altitude. Variation of G with altitude. Then we are going to discuss about variation of G with depth. Variation of G with depth. See, before that we know that G equals to G into 4/3 pi R cube by R square. So this is the volume into density. This one cancel. So GD, we are going to depth. G into 4/3 into pi into R minus D into density. When we are taking this ratio, all constants are cancelled. G by GD equals to what you are getting, density also cancel. 4/3, this one cancel. Simply you are getting R by R minus D. So GD equals to G into 1 minus D by R. It is common, even you are using when we are going into the mines also. This acceleration due to gravity is decreases here. Minus is there, no? G minus something means this is also decreasing like that. So you can you will say that GD is less than G when we are going inside the mines also. Suppose if D equals to 1000 kilometers, you know that radius of the earth, you should remember that 6400 kilometers. Then how to find out the variation of this one? G into G value we are taking 10. 1 minus D is the 1000. Then this is the 6400. After simplification, you are getting GD equals to 10 into 64 minus 10 is the 54 by 64, like that. So after simplification you can find out the variation of G with depth. Like that, next thing is the variation of G. Variation of G with latitude with respect to angle. At poles and at equator we should consider that angle with respect to angle. What about this one? That formula you should remember, that G phi equals to G minus R omega square cos square phi. Here R is the radius, omega is the angular velocity. So if at poles phi equals to how much? 90 degrees. Then G phi equals to, you can say that G, because cos 90 is 0, you can say this is the maximum. Like that at equator phi equals to 0 degrees. G phi equals to G minus R omega square. So here G phi is less than g means this is the minimum. You must remember these formulas. Depends on the angle also we can able to find out the variation of g with latitude. Then we are going to discuss about what is the orbital velocity and what is the escape velocity. What is the orbital velocity? See, based on this only, our satellites, technology and all these we are using orbital velocity. The minimum velocity required to revolve, the minimum horizontal velocity required to revolve around the planet or Earth. You can say this is the orbital velocity. This radius is r, this one is r plus h. So here it is revolving around, this means it is having the centripetal force, and you know all these expressions. Anyway, it is crash course, means directly I am giving V naught equals to under root gm by r. But instead of gm by r, we are writing gr also. So with the help of this, you can find out any planet orbital velocity. If it is Earth, it is different. If it is Moon, it is different. Based on that planet, you should find out. Then escape velocity. What is escape velocity? The minimum vertical velocity required to escape permanently from the planet is called the escape velocity. So we should write it V equals to under root 2gm by r plus h. Here you can take it r only. When you are using this condition, if h is very less than r, generally you are getting this is under root gm by r plus h, when we should consider height also. It should, if here also, if h is very less than r, you can use that ve equals to under root 2gr. Then what is the relation between escape velocity and orbital velocity? ve equals to root 2 times of this v naught. Suppose v naught equals to 7 kilometers per second. Then ve equals to how much? Root 2 into 7. You know that root 2 value 1.14 into 7. Then ve equals to how much? 28, 9, 28, then 9. So 9.898 kilometers per second. Like that, when you know the relation also, we can able to find out this one. These are very important, escape velocity and orbital velocity. You should remember, when you should consider the height, this is the orbital velocity, this is the escape velocity. If we are neglecting this, we can use in terms of mass or in terms of radius. From this, what you are understanding, orbital velocity is depends on the radius of the planet, escape velocity is also depends on the radius. Then geostationary satellite. What is the geostationary satellite? You know the time period of the earth is how much? 24 hours. So it is revolving around itself. It takes 24 hours. You can say that time period of the earth is how much? 24 hours. If any satellite, its time period is also 24 hours, you can say that geostationary satellite. You know that moon is the natural satellite of the earth. And we are using these days many satellites. What is the use of this one? They can able to find out the minerals, like we can able to forecast that different programs and different channels we can run that, and any weather changes also we can say that, and you know, any changes in atmosphere before 2-3 days or 15 days 10 days before also we can say that. So not only this one, for saving our country also, for monitoring other countries and all this, any people are coming, everything, even these days, no, they are sending one satellite for one purpose. One is for weather, one is for like roads quality they are monitoring, another one they are sending any weather changes, like that. There is, like, you know, we are completely depending on this satellite technology. It is coming from the orbital velocity, and these are the uses of the geostationary satellites. So this is about the gravitation chapter. Almost I have covered all formulas. This is the crash course. I can say this fast only, and please subscribe my channel and share to your friends also. Thank you everyone. For other classes also, already I have made 25 crash course classes, units and measurements, then motion in a straight line, motion in a plane, laws of motion, work energy, power, oscillation, and this is the gravitation. Slowly we are completing all chapters. Now the ball is in your court. You should prepare, and you can follow the MSET weightage chapters also and NEET weightage chapters also. Then I think it is very help to you. And I have given few constants to remember to solve the physics problems. All you should get when you are subscribing my channel and go through the playlist. Whatever you want, you can utilize in this moment. Thank you everyone.